Hello student, in this lecture we are going to discuss about mathematical model of control system. As we know, there are having three important model or three important representation of control system. So these three important representation are: one is differential equation model, second one is transfer function model, third one is state space model. So we can describe the control system in differential equation model or transfer function model or a S domain model or state space model. In this video, we discuss only differential equation model and transfer function model. This state space analysis, we are having a different chapter in control system. There we will discuss this state space analysis. So here differential equation model, we are going to describe our system according to differential equation. See, in the form of differential equation, where as in transfer function model, we are going to describe our control system or given system in terms of S domain or Laplace transform domain. So, for example, I am going to consider a system like this. This is RC network and this is purely electrical system. Now let current passing through this network is I, and here I am having an resistor R and a capacitor C. So this is my system. The output voltage is V0 across the capacitor, and here I am having input voltage is Vi. So this is the system I am having. So now here, if I want to write the equation for input voltage Vi, so this Vi is equivalent to RIT plus VCT, where RIT is the voltage across the resistance and VCT is the voltage across the capacitance. Now, so this is the equation of input voltage Vi. Now, I consider my current I in terms of capacitance. So, I equal to C dVCT by dt. So, current I passing through capacitor C is equivalent to I, which I can substitute in my input voltage equation. So, my input voltage VIT is equivalent to, in place of I can substitute R into, I can substitute I in this input voltage equation. So, VIT equal to R into C dVC dt plus VCT. Here I just put only VCT because here I am having no I factor. That's why I am writing VCT only. So you can see this equation in terms of differential equation, like VIT equal to RC into dVCT by dt plus VCT. This equation generally describes the functionality of this system. This system means RC system. So we can say this is called as differential equation model. Now if I asking what is the transfer function model? So to get the differential equation model, we just need to apply some general rules of the circuit like KCL, that means Kirchhoff current law, KVL, that means Kirchhoff voltage law, and after that we will get an equation. When we get the differential equation, then to get transfer function form, we need to apply the Laplace transform here. So you can see, if you apply Laplace transform here, then we are going to get VIS is equivalent to RIS plus 1 by CS into IS. Now I am taking common IS from this equation, so VIS is equivalent to R plus 1 by CS into IS. So this is the input transform. Now in the same way, the output voltage of the circuit is V0t, and this V0t is equal to VCT because in parallel voltage is equivalent to same. So this V0t is expressed by this equation, and after Laplace transform we are going to get V0 as equivalent to 1 by CS into IS. So this is the output transform. Now dividing the equation 2 by 1. So after dividing output transform by input transform, we get V0 as by VIS equal to 1 by 1 plus RCS. So transfer function of the system, that means system is RC network, is V0 as by VIS, which is output transform by input transform, and this transform is equivalent to 1 by 1 plus RCS. So this is the transfer function of given electrical system. Now come to the next circuit. This is the RLC network. In the same way, here after applying KVL, we get this input equation VIT equal to RIT plus VLT plus VCT. So after substituting I in this input equation, we find this differential equation. So this differential equation model represent this RLC system. Now after getting differential equation model of the system, to get transfer function model, we need to apply Laplace transform here. After applying Laplace transform, the input voltage is equivalent to RIS plus L S IS plus 1 by CS into IS. Now I am taking common IS from this equation. So this equation means input voltage equation VIS is equal to R plus LS plus 1 by CS into IS, and this is the input transform of the system. Now the output voltage equation is expressed the same way. We have seen this in previous case also. Then after Laplace transform, we find this equation, this output voltage equation. So this is V0S equal to 1 by Cs into Is. And after dividing output transform by input transform, we find this equation where V0S divided by VIS is equal to 1 by LCS square plus RCS plus 1. And this is the transfer function of given electrical system. Given electrical system means RLC system. So in this way we can find differential equation model or transfer function model of electrical system. Now here I have given some more example. So come to the third problem. This is our electrical system, and here we consider two loops. So in first loop we apply KVL, then we get this equation VIT equal to R1 I1t plus 1 by C1 integration of I1t minus I2t dt. And considering loop 2, we get this equation R2 I2t plus 1 by C1 integration of I2t minus I1t into dt plus L di2 dt plus 1 by C2 integration of I2 dt equal to 0. And at the output side, V0t equal to L di2 dt plus 1 by C2 integration of I2 dt. Now taking Laplace transform of the equation by assuming 0 initial condition on both sides are VIS equal to Ri I1s plus 1 by C1s into I1s minus I2s. From this input equation I am taking I1s common. So this equation is like this, where so VIS equal to R1 plus 1 by C1s into I1s minus 1 by C1s into I2s. After Laplace transform of second equation, then this equation is R2 I2s plus 1 by C1s into I2s minus I1s plus L into S into I2s plus 1 by C2s into I2s is equal to 0. Now I am taking common I2s from the second equation. So this equation is expressed in this way: 0 equal to minus 1 by C1s into I1s into S I1s plus R2 plus 1 by C1s plus LS plus 1 by C2s into I2s. Now set of equation governing the system can be represented in a matrix form as follows, like this. We can represent this equation in matrix form. Okay, so in this matrix I1s and I2s is equivalent to in this way. From this equation we simplify I2s. So we can so now we put this I2s in our V0s equation. After putting V0s equation I2s, we get this type of equation. From this equation we find the transfer function of this system. The transfer function of this system is like this, where V0s by VIS is equal to LS plus 1 by C2s into C1 into S divided by R1 C1 square S square plus C1s in first bracket. Next in first bracket R2 C1 square S square plus C1S plus L S cube C1 square plus C1S by C2 minus 1. Now come to the next example. This is our circuit. Same here, we consider two loop and applying KVL we find these three equation. After Laplace transform we find this expression. Then this set of equation governing the system can be presented in a matrix form as follows. From this matrix we calculate I2s, and after simplifying I2s we put this I2s in our output equation. Then after simplifying output equation we find this transfer function of the system, and the transfer function of the system is expressed in this equation. Okay, next come to another example, and this example same, we consider two loop. Okay, from this two loop we find differential equation. After differential equation we find the after differential equation to get transfer function form we need to apply the Laplace transform again here. After applying Laplace transform we find this expression, these three expressions. This is first expression, this is second expression, and this is the output voltage expression. And again from these two equation means first and second equation, we find this matrix. From this matrix we calculate the I2s. After simplifying I2s we put this I2s in our output voltage equation. After putting output voltage equation I2s we find the transfer function of this system, and this is expressed by this equation. Now this is your home assignment. So for this fourth system you people write the differential equation and find the transfer function. Okay, thank you.